Hello everyone, welcome to my channel. Today, I would like to talk about the fundamentals of coordinate systems for electromagnetic fields, and even it called as electromagnetic theory for ECE. EMF is for the EEE, and for ECE they call it as electromagnetic theory and transmission lines. Myself, Sai Kumar Tara, and these are my social media links like Facebook, Instagram, Twitter, and my YouTube channel. The YouTube channel name is Sai Kumar Tara. If you like my lectures, please like it and subscribe it and share to your friends too. And this is my Google site, that is Sai Kumar Tara 9. Today I would like to talk about the fundamentals required for electromagnetic theory, especially about coordinate systems. The best book I would suggest for EMF or electromagnetic theory, that is Sadiku, is one of the excellent book, and especially coming to this topic called fundamentals of coordinate systems. In Sadiku, he covered around 100 to 140 papers. Going through that one and getting knowledge is good. Reading a textbook is very good habit, but in my talk I would like to cover this topic in 20 to 30 minutes, where you can remember the essence and importance of these coordinate systems in very short time. Okay friends, let me begin my talk. uh, Okay, I would like to talk about the coordinate systems. Friends, we do have three coordinate systems. One is rectangular or Cartesian coordinate system. Second one is cylindrical coordinate system, and third one is spherical coordinate system. I have designed a model for this coordinate systems by my own creativity. Just I would like to show you that one. Okay, okay. Let me create a model like this. Uh, Let me call it as a system, that is coordinate system. The coordinate, every system needs an input, sorry, it's need an input, and every system gives you an output. Let me write it as, okay, OP and output. Okay, now what I'm going to take here is inputs to be like this coordinate, this three coordinate systems. One is RCS, CCS, and spherical coordinate system. For this three coordinate system, the inputs, let me consider the input is same for this coordinate system. What I have designed a model is the outputs will be three. That is, first one will be the representation, and second one will be the range, and third one will be the differential elements. This is what I have proposed. Differential element, let me write it as a DE. Fine. Okay, this is what I have described here. For all these three models, you need to uh, remember the things like this. First one, representation of it, range, and differential element. Even in differential element, there are three possibilities. One is differential length, differential surface, and differential volume. Differential length deals with the DL, that is single integral. Differential surface deals with double integral, and differential volume deals with the triple integral, that is line single, surface 2, and volume 3. Okay, friends. Okay, let me go ahead with the first rectangular coordinate systems. Done. Okay. Let me begin my talk with the rectangular coordinate system. Okay, rectangular coordinate system. That is the what was the first thing we have took? It is first one is representation. First one is representation. Guys, I am writing it as a freehand. Okay, representation. Second one is range. Second one is range, and third one will be differential element. That's it. Third one is differential element. Done. Okay. Okay, before going to this attack, The first representation of rectangular coordinate system or Cartesian coordinate systems are represented by x comma y comma z. Okay. Next, its range is represented like this: x ranges and y ranges and z ranges. Okay, z ranges. Okay. Before going to this one, I would like to draw one small figure for rectangular coordinate system like this. Okay. Let me consider its value axis to be here x-axis, y-axis, and z-axis. Okay, if I take it as an infinity line point charge from the origin, it goes towards a like this. Let me draw it as a dotted line. Okay, and it's ranging from uh, minus infinity to plus infinity for x. Similarly, it ranges same thing for y and z also. That's why the range I'm considering it as minus infinity to plus infinity, minus infinity to plus infinity, and similarly here also minus infinity to plus infinity I have considered. Next, coming to the differential elements, what I will do is I will change the color. The differential elements, what we took it is as a dl, ds, and dv for volume. Okay, for these three cases what I'm doing is I'm taking a small portion of this line and marking it as dx, and a small portion of this on y-axis, let me write it as dy, and similarly a small portion on this z-axis, let me write it as dz. Okay, similarly I'm considering a unit vector for this x-axis, that is ax is a unit vector. Similarly for y it is ay, and similarly for z I'm considering it as az. Now if I want to write a formula for differential elements, what should I do is just multiply this two, differential element and the unit vector. That is, I can write it as dxax plus, with respect to y it will be dy ay. Similarly with respect to z it will be dzaz. Okay, dzaz, done. Fine. When it's coming to the surface, a beauty thing available here is, if I want to have ax unit vector, then what should I do? I should discard this ax term and I should multiply only remaining ay and zz related terms like differential element. If you want ax, you should multiply the differential element of y and z. That's it. You should have you should have yeah, you should deal with yeah, you should deal with similarly, one second friends. Yeah, yeah, you should deal with similarly with ay also. What you need to do, if sorry it's not plus, if you want ay, then what you should do is you should discard ay terms and take only dx and dz. Then what do you get here? Sorry, what do you get here? Dx and dz. That's it. Similarly, if I want az, then what should I do? I should discard this az dz term and I should multiply this to dy and dx, that I get dx and dy. These are the three individual elements for surface. with respect to AX, with respect to AY, and with respect to AZ. Then coming to the volume, what you should do? You should multiply these three elements dx, dy, and dz. Then you will get an output to be like this: dx, dy, and dz. That's it, done with your rectangular coordinate system. Once again, I'm just recalling the things. Like in rectangular coordinate system, you should first remember the three things: representation, range, and differential element. Representation of rectangular coordinate system is xyz, and the range of rectangular coordinate system for xyz is from minus infinity to plus infinity. From this figure, I have wrote the equations for dl, ds, and dv. For dl, what I did is I took dx and ex, multiplied, and sum up with the dy ay. Similarly, sum up with the dz az. I got this expression. If you know dl, then very easy. For surface, it is dy dz with ax. If you want ax, you should discard this dx term and multiply this to. Done. If you want ay, discard this term and multiply remaining to dx dz. Done. If you want az, discard the az term and multiply only dx and dy. For volume, you need to multiply for the 3 dx, dy, and dz. Hope it is clear at your end. And I would like to go to the next one is CCS, that is cylindrical coordinate system. Similarly, even for the cylindrical system also, you need to remember these three funda. First one is representation. Let me write shortcut as RPE. Okay, representation. Then second one is range. Second one is range. And third one is similarly for the last like this DE, differential element. Okay, let me change the color for good visibility. Okay, for cylindrical coordinate system, the representation is rho. Especially in Sadiku, he write as a rho, whereas other people write it as r. We can use rho or r. Rho, phi, and z is the representation of the cylindrical coordinate system. Coming to the range, the same thing, like rho, phi, and z. Among this one, you know the value of z, right? In the last coordinate system, we have seen the value of z is what, from minus infinity to plus infinity was the value. Correct? Okay. Next, coming to the row range, it starts exactly from origin. It go till infinity, positive value. And the cylindrical coordinate system look like a circle-like structure, cylinder, and whose radius, that is angle, is 0 to 2 pi. Okay, I'm not going to draw big drawings for the cylindrical coordinate system. I have formulated one small shortcut. I would like to discuss that small shortcut to you with you all. What I'm going to write is, I'm going to write the representation like rho, phi, and z. Okay, its differential element is d rho, d phi, dz. Done. And whose unit vector is arrow, whose unit vector is arrow, a phi, az. Done. If you are able to write this one, then easy. Now I'm directly going into the differential element in as dl for line. What I did for the last case, I multiplied these two terms, and I multiplied this two terms, and I multiplied this two terms, and I added. Here a small twist you need to remember, that is just I'm multiplying this to d rho, a rho, okay, plus I'm leaving a space here. Let me tell you what the reason later. D phi, a phi, okay, plus same. dz az. Okay, just you need to add here to the phi, you need to add rho, which is very important. Okay, this is the shortcut. You need to remember the rho value should add it to the phi. That's all. If you are able to write equation for dl, it is very easy to write for ds also. For ds, same thing what we have done for the last class, last topic, that is, if you want arrow, what you should do, you should discard this term and multiply remaining two. What do you get? Rho phi d phi and dz. That's all. If you are able, if you want a phi, then what you should do, you should discard this a phi term. A phi term should be discarded and you need to multiply only this two, d rho and dz. Then what happens here, you will get a term to be d rho and dz. That's all done. Excellent. Now coming to the az, what you need to do, you need to discard the dz term and multiply remaining two, that is d rho and this d phi. What do you get here? You will get a term to be what? Rho d rho and d phi. Done. Excellent. You got values for the surface. Similarly, you want to have a value for the volume also. What you need to do, you need to multiply this all differential elements except the unit vectors. Then what do you get here? Rho d rho d phi and dz. Done. Okay, dz. Done. That's it, friend. This is for cylindrical coordinate system. One more is left over, that is spherical coordinate system. Hope it is clear. And let me go to the cylindrical coordinate system also. Cylindrical, sorry, spherical coordinate systems. Till now we have completed rectangular coordinate system, cylindrical coordinate system. The third topic is uh, spherical coordinate system. The same fund of what we have done for the last same thing. Representation is first point, second one is range, range, and the third one is same differential element dE. Okay, dE is a differential element. Done. Very good. I'm changing the color for good visibility. That is cylindrical coordinate systems, sorry, spherical coordinate systems represented as rho, theta, followed by phi. Okay, followed by phi. Same thing here. Already we have discussed the two values of the ranges in the last coordinate system. Only one is very new, that is theta is a new for us. Okay, done. And phi. Okay, the range of rho, you know, its ranges from 0 to infinity for rho. For phi also, you know, its value, it ranges from 0 to 2 pi, 0 to 2 pi. Whereas theta, its ranges from half of the phi, that means 0 to pi. Half of the phi value is range for rho. Similarly, now I am going to concentrate on its differential element like dl and ds and dv also. Friends, I am not going to draw very big drawings, and same style what I have did for the cylindrical coordinate system, the same is applicable for spherical also. First I am writing its representation theta, phi. Next its differential elements d rho, d theta, d phi. Next is a rho, a theta, and a phi. Okay, same thing I have written. Now what I need to do, I need to multiply these two terms and add them for the differential element. There is a one small twist. What we have seen in the cylindrical coordinate system, same will be also applicable for spherical coordinate system. Let me write an equation. Let me change the color to blue. Good. Okay. What you need to do, you need to multiply this two. D rho A rho is the first element. Done. Plus, I'm leaving the space, guys. Hope you can make a note of it. I have left a space followed by d theta, a theta, plus again I am leaving a space, a bit big space with the d phi and a phi. This d phi, a phi. What I did is I have multiplied this two similarly and I have put a plus mark. Now what I'm going to add a new terms here is, yes, I'm going to add older case what we have added in the second term, we have added row. Similarly, I need to add row here. For this case, what I need to add it, same row with sine theta, an additional term. Sine theta as an additional term. Guys, this is very important fundamental formulas to solve all complex problems in EMF and EMT. If you are able to remember the formulas for DL, then obviously you can work out for the DS. You can work out for DS. That is, if you want a term, if you want a term arrow, what you need to do? You need to discard this arrow term and multiply this two remaining terms. What do you get an expression? You will get expression to be like this: rho square sine theta, rho square sine theta. Uh, d theta d phi. That's it, done. Okay, and for d theta, if you want d theta, sorry, a theta, then what you need to do, you need to discard this a theta term and remaining terms you need to write. What will be the remaining terms? This first term and second term, third term will be available. Then what do you write it as? Rho sine theta, rho sine theta d rho and d phi. That's it. Very good. Done. Similarly, if you want to write for a phi, what you need to do? You need to discard a phi and remaining two terms you need to write it. Then what would be the expression for here? Rho d rho d theta. That's it. That's all. These two terms, rho d rho and d theta. This is formula for surface. We're coming to the volume. What you need to do? You need to multiply all the three terms. What do you get an expression? Rho squared, all these three terms. This, this term, and this term. All these three terms you need to multiply. What do you get? Rho square sine theta d rho d theta d phi. Done. Done with this coordinate system. Student get some doubts like, sir, how to identify whether this coordinate system is belongs to a cylindrical or spherical coordinate system. Let me give you a hint. Let me give an example like this: 2 comma 45 degrees, 45 degrees comma 5 means if you have one angle in the middle, then it comes under cylindrical coordinate system. Done. If you have expression like this: 2 comma 45 degrees and 15 degrees, if you are able to identify two angles in a system, then it comes under a spherical coordinate system. No angle like 2 comma 3 comma 1 If it is 2 comma 3 comma 1, then it is comes as rectangular coordinate system. Generally we mention it as meters. Okay, friends, hope you have liked my talk on coordinate system. I would like to discuss one more thing about this coordinate system. Most of the students get very what we call, they get some jitters in the stomach when someone asks you about what is divergence theorem and what is an expression for the Stokes theorem. Let me show you a one very small shortcut to you all. From there you can learn the theorems. What I have proposed my model like this. I have proposed a model to be like this. LSV. L stands for line, S stands for surface, and V stands for volume. Uh, line deals with the, sorry, lines, one second. Line deals with the single integral, okay, and whereas surface deals with the double integral. Line deals with single integral, surface deals with the double integral, let me write it as ds, and volume deals with triple integral. I'm writing here as v, triple integral dv. Okay, the shortcut you need to remember is sv. This is one shortcut, sv. Another one is ls. Okay, sv and ls. Yeah, ls. Okay, let me name like this. If I concentrating on surface to volume, it will be divergence. In shortcut I will make it as svd, like Swami Vivekananda means divergence theorem. That's it. Okay, divergence theorem deals with the relationship between surface to volume. Okay, whereas coming to this ls, let me make it as in between, yes, like a Stokes theorem. Okay, let me write it as lss, love someone is known as Stokes theorem. That's it. Okay, love someone is known as Stokes theorem. It shows the relationship between line to surface. Whereas coming to divergence theorem, Swami Vivekananda shows the relationship between surface to volume. If I want to write an expression for the divergence theorem, it will be like this, means a vector with surface ds is equals to a volume integral with, we will write it as del dot product will be for divergence. Okay, del dot a into dv. That's all. This is a formula for divergence. Whereas coming to the surface, Stokes theorem, it will be like this. Okay, same formula. One second, friends. One second. Okay, for surface it will be like this. Okay, single integral a, single integral into dl is equals to integral del, here it will be a cross product into a ds. That's all. This is Stokes theorem and this is divergence theorem. Hope you like my presentation. Thank you so much. Do watch and do like my videos. Thank you all.